All right, welcome. In this video, we're going to talk through some solution stoichiometry. And if we're thinking about what stoichiometry is, remember that stoichiometry is just a calculation involving a chemical reaction. So if you've got a chemical reaction, you've got a balanced chemical equation describing that reaction, then you can do some calculations involving this reaction. For example, down here, we see the reaction between nitrogen and hydrogen gas to form NH3, which is ammonia. And we could figure out, like, if 75 grams of nitrogen reacts, how much ammonia would we form? And the process that we went through for this is our first step was always find moles. Remember, so we converted mass to moles using the molar mass. Then we used the coefficients in the balanced chemical equation to figure out the moles of whatever we're trying to find. So like in this example, maybe we know moles of nitrogen and we're trying to find moles of ammonia. So we'd look at this equation and say that nitrogen and ammonia are present in a 1-to-2 ratio. So however much nitrogen we have, we're going to have double that of the ammonia. So that's how we're using our coefficients. That's our mole ratio. And then the last step, if we get that far, depending on what the question is asking us for, would be to find mass of our final product. So once we know moles of ammonia, we could find grams of ammonia by looking at the molar mass. So molar masses are something you find on the periodic table. The coefficients you get from the balanced chemical equation. So that's a reminder from Unit 7. And we have other videos on stoichiometry from Unit 7. But now let's talk about solution stoichiometry. So now that we know something about molarity and we know what molarity is, then we can do some stoichiometry with these aqueous reactions, and we can incorporate molarity into our process, into our calculations here. So what I have here, this is what I like to call, what people commonly call the mole map, kind of as a guide to show us how we might get through these types of calculations. And so this mole map just had grams and moles on it. Now our mole map is expanded. So now we can find more things now that we know something about molarity. So some differences are there's a few more things on here, right? We got some extra branches on our map. But what is similar is when you go through these processes, the first step is always to find moles. The next step is to use your mole ratio. And then the final step is going to be, that's going to vary based on what the problem's asking for. But step 1 is always find moles. Step 2, use the mole ratio. Keep that in mind. So what we are using here is, since we know if you have a solution and we know the molarity of the solution, we know molarity is moles per liter. So if we have a solution of a known molarity and volume, we can figure out moles. Then we could use the mole ratio to figure out how many moles of, let's say, product we would form. And then we could maybe figure out the molarity of the solution, or we could figure out grams. We have several options where we can go from here. So let's look at some example problems so we can see what this looks like. And these are from page 16, our solution stoichiometry page here. So we've got this reaction here. We've got nitric acid and potassium hydroxide that are reacting. And the question is, what volume of HNO3 would you need to neutralize this much KOH? So first step, if we take a look at our kind of mole map here, is to find moles. So I'm going to see if there's one reactant that I know the molarity and the volume of. Okay. And looks over here, it looks like we know the molarity and the volume of KOH. So KOH is 0.48 molar. The volume, remember we want to convert milliliters into liters. We want to divide it by 1,000 to get liters. And so if I stop and I multiply that, so 0.48 times 0.025, I get 0.012 moles of KOH. Cool. The question is asking me for volume of HNO3. So let's look back at my map here. First step is to find moles. Second step is to use this mole ratio. So I'm going to look back at the equation, and this says that for every 1 KOH, I'm going to react 1 HNO3. So it looks like a 1-to-1 ratio. So 1 KOH for every 1 HNO3. So that means I also need 0.012 moles of HNO3. Okay. And then the last step is going to vary based on the problem what the problem's asking you for. In this case, the problem's asking me for volume. It's like I'm trying to find volume, so it's how many milliliters, and it's giving me molarity. So we know that molarity is the moles per liter, right? And we know that the molarity is 0.85 and the moles is 0.012, and then the liters is the unknown here. So that's what we're trying to solve for. So let me kind of draw a line here to separate this. So to find the volume, I would end up taking my 0.012 moles divided by my molarity, which is the moles per liter, and 0.85, you end up getting 0.014 liters. And we usually are going to measure that in the lab in milliliters. So I'm going to multiply that by 1,000 to give me milliliters. So what I'm saying is I need 14 milliliters of 0.85 molar HNO3 to neutralize 25 mils of 0.48 molar KOH. All right, let's take a look at another problem here. It looks like we have a known amount of KOH. We got a volume and molarity for KOH. We've got a volume for HNO3. And the question here is asking us for concentration. So we're trying to find the molarity of HNO3. All right, so remember, first step, if I go back to my mole map, is going to be to find moles. So I'm going to take my molarity times volume to find moles. All right, so my molarity is 0.2, and my volume is 0.065. I got to convert my milliliters into liters. Okay, so 0.2 times 0.065. I end up with 0.013 moles of KOH. So that's how much KOH reacted in this scenario. And I'm trying to find something about HNO3. So my next step is to use my mole ratio to go from moles KOH to moles HNO3. And it looks up here again, this is a 1-to-1 ratio. So remember, there's no number written down in front of something, that there's a 1 there. We assume that means there's just one of that substance. So for every 1 KOH that reacts, it looks like 1 HNO3 also reacts. So that means we reacted 0.013 moles of HNO3. And then the question is, what is the concentration? So the concentration is measured in molarity. Molarity is moles per liter. So we have 0.013 moles of HNO3. And then the volume of HNO3 is 0.150 liters. Again, remember to convert your milliliters into liters. And so you end up with a final answer of 0.087 molar. If you rounded it differently, that's fine. But we kind of get the general idea here. All right, so these are examples of a 1-to-1 ratio. So let's take a look at an example where it's not a 1-to-1 ratio. So this problem, we said, okay, we want to neutralize 4 moles of H3PO4, so 4 moles of H3PO4, and you're trying to find moles of calcium hydroxide. So if I look back at my mole map, this is actually just a one-step calculation. I'm just going from moles H3PO4 to moles calcium hydroxide. So just one step there. So I'm going to use my mole ratio. And my mole ratio tells me that for every 2 H3PO4 that react, I am going to use up 3 calcium hydroxides. So 4 times 3 divided by 2 is 6. So that's how many moles of calcium hydroxide are needed to neutralize 4 moles of H3PO4. And you don't have to set it up this way. You could set it up different ways, right? You could use your ratios. You could say that 3 calcium hydroxides per every 2 H3PO4 is, X divided by 4. However you do the math, set up your math there, totally fine. Just make sure you show your work. Yeah, there's different ways of kind of showing how to get to that same answer there. Okay, let's look at one last problem. So we've got a given volume and molarity of calcium hydroxide, and then we've got a volume of H3PO4, and we're trying to find molarity. All right, so our first step in a calculation is to find moles. So I'm going to take my molarity times my liters to find moles. Let's go back and do that. So we've got my molarity is 0.10. My liters is 0.04. So 0.1 times 0.04 is 0.004 moles of calcium hydroxide. And I'm trying to find molarity of H3PO4. So my next step is I want to do the mole ratio. So it's 0.004 moles of calcium hydroxide. And then if we look at the balanced chemical equation, they react in a 3:2 ratio, meaning that for every 3 moles of calcium hydroxide that react, we're going to use up 2 moles of phosphoric acid. Okay, so that's times 2 divided by 3, and that's 0.0027 moles of H3PO4. So what we know so far is that 0.0027 moles of H3PO4 reacted. So if that's how much H3PO4 was present in this solution, what is the molarity? Well, the molarity is the moles per liter. So we've got 0.0027 moles of H3PO4 divided by 0.2 liters. So that gives us 0.013 molar. So that's the concentration of our H3PO4 there. All right, so there's some practice problems. Please send me a chat message if you have follow-up questions on this one, and hope this helps.